And this is where we're actually going to get into some of the postulates, the bigger ideas of what we're doing with points, lines, and planes. So first thing you need to know is just what a postulate is. You'll hear postulates, you'll hear theorems, you'll hear different things throughout the year. A postulate, when they say this is postulate 1-1, that's something that you just get to accept as fact. Like, we know this is true, okay? A theorem is something that needs to be proven. So a little different, but postulates, it's just like, yep, this is true, okay? All right, here we go. So the first postulate says through any blank points, there's exactly one line. Any guesses how many points you would need to make one line exactly? Two, right? If you have 2 points, that's not a pen. There we go. So if you have 2 points, you'll get one line. In other words, if I were to put a point here and I were to put a point here, there's only one line that can go through that, right? So I would go like this and make my line, okay? An intersection, are any of you drivers? Who's got their license? A few of you? Permits? Okay, what's so strange to me? Nobody gets their permit these days. When I was in school, it was like, I turned 15, now you guys had to be 15 and a half, huh? So some of you just aren't old enough. But we turned 15 and it was like we got our permit that day. And we turned 16 and we got our license that day. People just don't get their license anymore, huh? It is expensive. It's totally expensive. That's a bummer because that was like such a huge day for me. I was so excited. Okay, anyway, intersections brought me to cars. So think intersection on the road. What's happening? What's an intersection? It's a crossing, right? It's where two roads crisscross, they meet each other, they intersect. So an intersection is the set of points that 2 or more figures will have in common. And you're going to see a lot of intersection in this lesson. So we're going to jump. I'm really sorry. The tickle just won't go away. We're going to jump into a couple more postulates that deal with intersections. And then you're going to have to find intersections as we go through a bunch of pictures. So postulate 1-2 says if 2 distinct lines intersect, they intersect in exactly blank point or points. So think 2 different lines. So I have a line here, and I'm going to draw a line that intersects that line. How many points do they meet at? Jared. Yes? 1, right? Now, sometimes people are like, wait, what, couldn't it be like a whole bunch of points if they are in the same spot? And I see what you mean by that, but this is the key word here. If 2 distinct lines, so those are 2 different lines. In other words, I can't have this line and this line because they're the same line, right? So that doesn't work. If 2 different lines intersect, they intersect in exactly 1 point. Questions on that? All right. Postulate 1-3. Now this one says if 2 distinct planes intersect, then they intersect in exactly 1 blank. And if you want to look a little later or as you're doing your homework at page 30, there's a good picture that helps you to see this. But what do you think their intersection is?
1 line or axis.
A line, or, oh, you're fancy. You're looking in the book, huh? 1 line is correct. Okay, now here's my question. If I had 2 planes, let me draw you a little picture here. And this is not as beautiful as the book. I apologize, but you'll get the idea at least, I think. Okay, so 2 planes, right? When you draw the 2 planes and you see where they meet, that would be this line right here. Why did we say it's a line and not a segment? Doesn't that look like a segment? Why is it a line, not a segment? Daniel.
Because planes go on forever.
Right. So even though we can't draw a plane going on forever, it does. So the fact that the plane goes on forever, that means its intersection goes on forever. So technically, its intersection is this black line right here. Does that make sense? Okay. Think of it like my wall over here and my floor, right? If my floor is going this way and my wall is coming this way, where they meet is that corner, okay? But the floor keeps going and the wall keeps going forever. So then their intersection goes on forever too. Okay, so let's try a couple of these. It says name the intersection of plane ADC and plane BFG. I don't know if you've noticed, but I'm a color coder. I love color. So I do a lot of shading in different colors just to help me see visually. If you are a visual person, that might be helpful to you. You are welcome to shade and do whatever you need to with these pictures. On a quiz, on a test, shade away, okay? But what I would do in this setup is I would take plane ADC, okay? So can anyone tell me which plane that would be? Top, bottom, left, right, front, back? Anyone other than Daniel have an answer for me this morning? Yes, Matthew. Which plane is ADC? The top one, right? So A, D, and C. Here's A, here's D, here's C. That represents this plane. Okay. What would plane BFG be? Did you say it, Braden? I saw the mouth move. The right one. So BFG, here's B, here's F, here's G. That would be this plane. Okay, so the question is the intersection. What's the intersection of two planes always going to be? A point, a line, a plane, a line, okay? So which line is the intersection there? Line BC. How do you write line BC? Daniel.
You write capital B, capital C, and you draw a line with 2 arrows on each end.
Right, got to put the arrows on. Oh, you know what? I should do this up here. We're going to go up here. So BC, and then make sure you put the arrows over top. Okay? Let me get this out of here. Yeah, Matthew.
Would it be okay if you instead of putting the line sign over the name of the line?
Write the word line BC. Yeah, that's fine. It's more for you to write, but I'm totally fine with that. All right, next one says, name two planes that intersect in EF. So before they told us the planes, they wanted the line. Now they're telling us the line. We want to know the two planes where they meet. Question. Yesterday you learned how many points you need to name a plane. What's the minimum? 3, okay? Can you use more than 3? Yes. So for some people, it makes more sense when you're using a square plane to use all 4 points. That's totally fine. If you want to just use 3, you can use 3, but you cannot use 2 because 2 would make a line instead of a plane, okay? Okay, so it says name 2 planes that intersect in EF. So here's our EF. Can someone name one of the planes that meets at EF? Is this, like, are my question answers just going to keep moving so it moves into all the rest of you? We're getting better over here. Come on, someone's got to give me an answer. I know these guys got it now. I need to know the rest of you do. Yes. EFG. Say it again. EFG. EFG. Okay, that would be the bottom one. Dylan. Yes. EFG. So plane EFG. And plane what? What would the other one be? Will. Not Will. Jared. Oh, you're not so sure. Who's Will? You're Will. Sorry. Do you know it, Will? Which one, where EF would meet, which 2 planes is the intersection? EF. So we said EFG, this bottom one. What's the other plane that meets at EF? Not, that would be the same plane, right? EFH would be that same bottom plane. So now we need the, Raven, AEF would work, yes, plane AEF. That would be the front plane, right? This one here. Okay, questions on that? Okay. Did I show you my little crossovers? Here we go. Last little bit here. Postulate 1-4, through any blank non-collinear. What's non-collinear? You learned it yesterday. Not in a line, not in a straight line. So through any blank non-collinear points, there's exactly one plane. This is my favorite postulate. What's the number? Matthew, 3. And I told you it yesterday, so maybe you remember it, but we're going to go a little more in depth now. So through any 3 non-collinear points, there's exactly one plane. Hold up 3 fingers, but not in a straight line. Okay? Now take those 3 fingers and lay it on your flat desk. Are they all touching your desk with your fingers straight? They should be, right? Think about a photographer. How do they steady their camera? With a tripod, right? Not a quad pod. That would not be a good steady surface. If you think about like my stool, there is the potential on this stool to have a wobble. I don't know why they don't make more 3-legged stools actually, because the 3 is actually more steady because the 3 will always rest on the plane. But anything that has 3 points will always go through one plane. So like yesterday we were talking about, I don't know if I used heads in here. Did I use people's heads? My head and Sarah's head and that tree over there, okay? I can put a plane through those 3 things. So my head to Sarah's head, it's gonna tilt this way a little bit, but then it's also gonna tilt that way and go through. So any 3 points will always have one plane. Does that make sense? Okay. So, example 4 here, what plane contains points N, P, and Q? N, P, and Q. Do you see it? Which plane would that be? Top, bottom, left, right, front, back. Raven. Bottom. N, P, Q. So here's your N, here's your P, here's your Q. So that would be that plane. And I'm just going to shade here to show you which one's which. So the red plane would be N, P, and Q. What plane contains J, M, and Q? And this one always throws some people off a little bit. What's the issue here? It's not a plane that's drawn in, right?
It's cutting horizontally through the rectangle, like from J to N to Q.
Yeah, not necessarily horizontal, more it's on a slope, right? It's diagonally. There you go, cutting through. So you have J, you have M, and you have Q. What would be the 4th point that would work well with that? P, okay? So here's what you do with those. If the plane isn't drawn in for you, just draw it in, connect the points. So I would draw this line in, I would draw this line in, and then I would shade that plane. So it's like if you took a Kleenex box, right? It's basically saying, here's J and M, Q is down here, so I'm cutting that Kleenex box diagonally here, okay? So that's our blue plane. And then the last one, M, L, and Q, which plane would that be? Front, back, left, right, top, bottom. It's the back plane. So that would be back here. All right, you have M, L, and Q. So here's M, here's L, here's Q. R would be your 4th point there. Questions on that? Let me make sure I got all I wanted to get. I believe we did.